So use the graph to answer the question, which of the following transformations map polygon ABCD to itself? There's more than one correct answer choice. Select all correct answer choices. Okay, so mapping it back onto itself means that this image just ends up being right here and not somewhere like over here. That's not mapping it back onto itself. So if the image can just be recreated right back on here. So to check that, I would first just think to myself, okay, a reflection in the x-axis would take point A, and it would be one distance away, and so point D, it would end up being on point B. Point B would end up being 1 unit to the right as well. And C, since it's 1 unit up, it would be 1 unit down. And D would end up being, since it's 1 unit up, it would end up being 1 unit down. So a reflection in the x-axis does map it back onto itself because the square would be right here. So 180-degree clockwise rotation about the origin. So to check that, I'm just going to check point A if I were to rotate it 180 degrees. So from point A, it is back 1 and to the left. So rotating at 180 degrees, it would be this way and to the left. So C would end up, A would end up being where C is. D would end up being up 1, back 1. So take this line and move it right here. So it would end up being where B is. So it does map itself back onto it. I'm not checking the other two because I am using some prior knowledge that rotations and reflections are rigid transformations. So if one point A has to move right here, then that means that D and B would also have to move that same distance, and so it would map itself back onto it. So then we would have a reflection in the line in the y-axis. How would we check that? Well, A is 1 unit away from the y-axis in the left direction, so it would end up being 1 unit away in the right direction. Same thing for D. D is 1 unit in the left direction, so now it would be 1 unit in the right direction. B is 1 unit in the right direction, so now it would be 1 unit in the left direction, and C is 1 unit in the right direction, so it would be 1 unit in the left direction. So it would end up mapping itself back onto itself. A reflection in the line y equals x. So in order to check this, I have a hard time visualizing the line y equals x and rotating it around that. So what I have used is I know that x and y, my original x coordinates when I reflect about y equals x. So when I reflect about the y equals x, what ends up happening is your y coordinate becomes your x coordinate, and your x coordinate becomes your y coordinate. So I'm going to just check one of the coordinates. I'm going to check point A, which is located at -1, -1. So after it's reflected about the line y equals x, we have our the y value becomes our x value, and the x value became our y value. So it does end up giving us the exact same coordinates, and so this does end up being correct. 90-degree clockwise rotation about the origin. So again, if I'm talking about a rotation, I'm checking point A. A rotation is a rigid transformation, so everything else would shift relative to A as well. So I'm just going to check A and see if it ends up landing at one of these coordinates. So a rotation 90 degrees clockwise. Okay, a 90-degree clockwise turn. So it's back 1 into the left. So 90 degrees would end up having it be right here. So yes, A does end up being back on this square. And so that does map it back onto itself. So all of them ended up mapping it back onto itself. And I hope that helps.